Hello folks, welcome back. I'm sorry I was a little delayed on the videos this week, but we're going to discuss the last sections of Chapter 8 today. In this first section, we're going to talk about different units of mass and energy. So everything we've discussed so far has been talking about mass in terms of kilograms, energy in terms of joules, because we've been dealing with things that are large scale, things that you can see. And so those objects have masses that are generally around a few kilograms and energies around a few joules. But if we're talking about things like electrons and atoms and nuclei, those units are way too large to talk about the differences between those different types of particles. So we use different units when we discuss electrons and nucleons because it makes the numbers much easier to deal with and it allows us to compare the two. So the atomic mass unit is approximately the mass of a hydrogen atom. So one atomic mass unit, or 1U, is 1.66 times 10 to the minus 27 kilograms. It is about the mass of a proton by itself. The actual mass of a hydrogen atom, 1.008 U, or atomic mass unit. The atomic unit of energy is called the electron volt. It's defined as the energy gained by an electron accelerated through a potential difference of 1 volt. 1 electron volt, or 1 eV, is equal to 1.6 times 10 to the minus 19 joules. When we talk about electron volts, they're typically used to discuss the energy needed to remove electrons from an atom. If we want to take or knock an electron off of an atom or take it away in some type of chemical bond. If we want to talk about nuclei, the energy to remove nucleons is much, much greater than the energy to remove electrons from an atom. And so when we're talking about nuclear physics, when we're talking about nucleons inside of the nucleus, we just use mega electron volts, or MeV, which is just 10 to the 6th electron volts. It's like similar prefix to megabytes, which is another metric prefix that refers to 1,000 electron volts, or 1.6 times 10 to the minus 13 joules. So let's take a look at an example here. We want to find the kinetic energy of an electron, and this is the mass of the electron, with a speed of 1.85 times 10 to the 6th meters per second. And then we're going to write the answer in electron volts. So, just like before, we can find the kinetic energy of an electron using the same formula we've used before, 1/2 mv squared. The mass of an electron, 9.11 times 10 to the minus 31 kilograms. The velocity is 1.85 times 10 to the 6th meters per second squared. And if you plug this into your calculator, you should get 1.55895 times 10 to the minus 18 joules. We want to write the answer in electron volts. So this is just a unit conversion. 1.55895 joules, times 10 to the minus 18 joules. We just want to convert this to electron volts. So if we just go back and look, 1 electron volt is 1.6 times 10 to the minus 19 joules. And so 1 electron volt, 1.6 times 10 to the minus 19 joules. And when you divide, joules will cancel, and you're left with an answer in electron volts, and you should get 9.74. And so here we're talking about the energy of an electron moving at a particular speed, and it's about 10 electron volts. And so it's an easy number to talk about. It'd be easy to compare to another electron that had an energy of, say, 8 electron volts or 12 electron volts. We'd be able to tell the difference between those three relatively easily. But it's a lot harder to tell the difference between that and units of times 10 to the minus 18. And so we use electron volts because it just makes the numbers easier to deal with and easier to talk about. So let's say we want to find the speed of an electron with a kinetic energy of 375 electron volts. Well, we can just convert that to joules. 375 electron volts, 1 electron volt, 1.6 times 10 to the minus 19 joules. And when you multiply those two, you get 5.2 times 10 to the minus 14 joules. Now we have the energy in joules, and we know the mass of an electron from the previous problem. We just have to calculate the velocity. And so the kinetic energy, 1/2 mass times the velocity squared. There are a couple of ways you can do this. I'm going to show you that you can just divide by 1/2 m on both sides. And that leaves you with v squared is going to be equal to the kinetic energy, 5.2 times 10 to the minus 14, divided by 0.5, or 1/2, times the mass of an electron, and we wind up with v squared is equal to 1.14160 times 10 to the 14th meter squared second squared. But then we have to take the square root of both sides. And we're left with a velocity of 1.068 times 10 to the 7th meters per second.